Hi there, this is a geometry video. It is chapter 6, section 3, and today we are talking about tests for parallelograms. In our previous lesson, we discussed what the definition of a parallelogram was. We had several theorems that stated that if a quadrilateral was a parallelogram, then certain things happen. And what you're going to have in this section, for the most part, is all of the converses to the theorems that we had in 6.2. But again, to condense some of the note-taking process, I've basically put on the board those converses here. Now, the one that's asterisked is one that is not a converse of the previous lesson. It's a whole new theorem. But the first three are converses of the theorems that we had in 6.2. So basically what we have is if any one of these four things happen, then that proves that the quadrilateral in question is in fact a parallelogram. So basically in the previous section we knew it was a parallelogram, and because it was a parallelogram, the four things happened. In this case, that's why it's called test for parallelograms. We're actually testing to see if in fact it is a parallelogram. We don't know that it's a parallelogram, we're testing to see if it's a parallelogram. And it will be a parallelogram as long as one of these four things happens. Okay, so the first is if both pairs of opposite sides are congruent. So I have here a diagram of a parallelogram, and so basically if AB is congruent to DC, and in turn AD is congruent to BC, then yes, this will be a parallelogram. The second option is if both pairs of opposite angles are congruent. So if angle A is congruent to angle C, and if angle D is congruent to angle B, then again it will be a parallelogram. And these are all the converses of the ones that we had in the last section. Third option is diagonals bisect each other. So basically if AP is congruent to CP and DP is congruent to BP, which is the diagonals bisecting each other, then it's going to be a parallelogram. And our last one is not a converse, and it doesn't require both of anything. So I just wanted to really point this one out to you. This one is saying that you only need one pair, but you need two things to happen. You want one pair of opposite sides that is both parallel, my symbol there, not 11, but parallel. One pair of opposite sides that is both parallel and congruent. So you have two options here. You can have the one pair be AB and DC. So basically if AB is parallel to DC, and also if AB is congruent to DC, then it's a parallelogram. Or the other option would be to have the other pair of sides. So AD parallel to BC and AD congruent to BC. So one of those two options could happen. If any of these four options happens, then you're going to have a parallelogram. So let's go to our examples. It says, determine whether the quadrilateral is a parallelogram. Justify your answer. So we have our example one over here. And what we can see is that we have one pair of opposite sides congruent, but we don't know that F, J, and GH are congruent. So we can't really base it off of both pairs of sides congruent. And we don't know that any of the sides are parallel. So we can't base it off of the fourth option. But what we can do is we know that the consecutive interior angles, remember we talked about that before? One of the definitions of parallelogram was that the consecutive interior angles had to be supplementary. So in this case, 180, so 100 plus 80, so angle G plus angle H equals 180, which means that those two angles are supplementary. So sorry. All right, so this one's going to be option number, sorry, I had to check something real quick. We're going to go with option 4 here. We know that in option 4 we have one pair of opposite sides parallel and congruent. So what's happening here is that we know that FG, we have to justify, so let's do FG is congruent to JH, we know that, but also we know that FG is parallel to JH, and the reason why we know that is because these two angles are consecutive interior angles, and they happen to be supplementary, and that was like a few chapters back. But basically, if these two angles are supplementary, then FG is parallel to JH. And this is the transversal. And so because we have one pair of sides that is both parallel and congruent, then this is a parallelogram. So the answer here would be yes. Alrighty, so now I need you to do the same thing with these two, and then we're going to move on to our next example. And this is a more algebraic example. And yes, I skipped example 2, but I'm well aware of that. It's okay. So we're going to go to example 3. And example 3, we're going to use some algebra. And it says here, if fk, so here's my fk, is 3x minus 1, and kg is 4y plus 3, jk is 6y minus 2, and kh is 2x plus 3, so I'm just filling in my diagram. Find x and y so that the quadrilateral is a parallelogram. Well, the only way for this to be a parallelogram is if the diagonals bisect each other. So we have to see what the x and y values would be if the diagonals bisected each other. So basically, we need fk minus 1 to equal kh, which is 2x plus 3. At the same time, we need jk, which is 6y minus 2, to equal kg, which is 4y plus 3. So basically, we have ourselves two separate equations that we need to solve for x and y. So here we're going to subtract 2x, add 1, 3x minus 2x is x, and 3 plus 1 is 4. So the x value needs to be 4. In the case of the y's, we subtract 4y from both sides. At the same time, we can add 2 to both sides. So 6y minus 4y will give you 2y, and 3 plus 2 will give you 5. Divide both sides by 2, so y has to be 5 halves in order for this to be a parallelogram. That would indicate that the diagonals bisected each other, and therefore it would be considered a parallelogram. So now we're going to have you try to do it yourself, number 3. And then we're going to move on to example 4. And in example 4, they want us to use coordinate geometry. So it says graph quadrilateral KLMN with vertices K, 2, 3. So we're going to do that first and foremost. K is 2, 3, so here's 2, 1, 2, 3. That's K. Then we have L is 8, 4, so here's my 8. And 4 is going to be roughly, trying to make this somewhat as accurate as possible, up here. That's going to be L. M is 7, negative 2, so here's 7, and negative 2 is right about here. And that is M. And lastly, we have N, which is 1, negative 3. So right about there. This is going to be N. So we're going to connect these little guys. Now they do want us to graph it, so we can't, it's not enough to just give the answer. We have to graph it. It does say to graph the quadrilateral. There we go. That's the first part. And then it says, determine whether the quadrilateral is a parallelogram. Justify your answer using the slope formula. Now there are obviously a couple of ways that you could actually justify your answer. You could justify your answer by using the slope formula, because we know that opposite sides of a quadrilateral have to be parallel in order for it to be a parallelogram. So we could use the slope formula to calculate the slope 4 times and confirm that they're actually parallel. But you could also do distance formula, because we could also verify that all of the opposite pairs have the same distance. And you could also prove it with the midpoint formula, because we could take the diagonals and find the midpoint of both diagonals, and if the midpoint of both diagonals was the same, then again the diagonals would bisect each other, and that's another way that you could do that. So, but right now it says to justify my answer using the slope formula. So I'm going to use the slope formula, and I have to find the slope basically 4 times. So I'm going to start with KV, and K was 2, 3, and V, sorry, not V, L. I thought that was a V because of the way it's written, but it's an L, and L was 8.4. I also have to find the slope between N and M, and N is 1, -3, and M was 7, -2. Okay, so to find the slope, if you remember the formula, it's y2 minus y1 over x2 minus x1. So this is x1, y1, x2, y2, x1, y1, x2, y2. So my slope is going to be y2, so 4, minus y1, which is 3, over 8 minus 2. 4 minus 3 is 1, 8 minus 2 is 6. So I get 1/6. Over here, I'm going to go y2 is -2, minus y1, which is a -3, over x2, which is 7 minus 1. So remember that when you have minus negative, that's a plus. So it says -2 plus 3, which is 1, and 7 minus 1, which is 6. So far so good. We got 1/6 for both of them. But now we want to try to find the other pair of sides also be parallel. So we did KL already. So now we're going to do KN. K and N. And we're also going to do L and M. So L and M. And do the same thing, x1, y1, x2, y2, x1, y1, x2, y2, and calculate the slope. So y2 is going to be -3 minus 3 over 1 minus 2. -3 minus 3 is -6, and 1 minus 2 is -1, so you get +6 for your slope here. And in the LM case, you're going to go -2 minus 4, and then 7 minus 8. So we're going y2 minus y1, so -2 minus 4 is -6, and then x2 minus x1 is 7 minus 8, and 7 minus 8 is going to be -1. So -6 divided by -1 is +6. So again, we get the same slope for the other pair of sides as well. So now we've justified that this is in fact a quadrilateral by using the slope formula. So now you are going to try 4A. And in the case of 4A, they want us to basically, you don't have to graph it this time. It doesn't ask you to graph. But you do need to verify that it's a parallelogram by using the distance formula. Remember how I said before, if all four sides have the same distance, then that's going to prove that it's a parallelogram. And in part B, they want you to use the midpoint formula. So you need to find the diagonals and find the midpoint of each diagonal. So it is helpful to at least draw out the parallelogram so that you know which points to connect to which when you're doing that. All right, so our last example is a proof. And I know how much you love those. But luckily this time our proof is actually going to be a coordinate proof, and so it shouldn't be as complicated. The hardest part is probably explaining to you how I set up my diagram here, and I did do it ahead of time, but I want to kind of walk you through it. So it says write a coordinate proof for the following statement. If one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So to do a coordinate proof, you kind of have to have coordinates. So what I've done is I've strategically and conveniently placed my quadrilateral on the XY plane in such a way so that the one pair of sides is parallel and congruent. And then I'm going to prove it by taking the slope of the sides and proving that it's the same. So this is what's happening here. I put one vertex of the parallelogram at 0, 0. So basically what I'm saying here is that point B is over here, and since point B x coordinate is A, it means that the length of this is A. Alright, now up here what I've done is I had to move the point in a little bit. So I can't call this A, because if it was A, it'd be the exact same distance. A would be right here. So this cannot be called A, but it can be called B. And if I call it B, then I'm going to add A to it, because, like, for example, if this segment is 3 units long, and then this segment starts, but this segment starts at 0, so this is going to be 0, and this is going to be 3. But if this point is starting at 1, and I still want this to be 3 units long, I have to add 3 to it, so it's going to be 1 plus 3, in other words, B plus A. So I hope it makes sense why I chose those letters, but I have 0, 0 over here, A, 0. This is going to be called B, the x-coordinate, and the x-coordinate of point C is going to be B plus A. Now that guarantees that both of these sides are congruent. They're both a length of A, okay? And then the other thing that I did is I made sure that these are both C, and the reason for that is because now the slopes will be the same. We know that anytime you have a horizontal, two horizontal lines are always going to be parallel to each other. So these are not horizontal, but this top one and that bottom one are horizontal. The y-coordinate of both of these is 0, and the y-coordinate of both of these is C. And whenever you have the same y-coordinate, you have basically a horizontal line. So that means that they're parallel. So I strategically placed the diagram on the coordinate plane in that way so that I could do that. So now we've done all that, we want to actually write our proof. And to write our proof, we're basically going to use the slope formula to calculate this. So I'm going to find the slope of, first we're going to do the slope of AD. And just like the previous example, the coordinates of A are 0, 0. And the coordinates of D are B and C. So I have my x1, y1, x2, y2, and my slope is going to be y2, which is C, minus y1, which is 0, divided by x2, which is B, minus x1, which is 0, and I'm going to get C over B. That is my slope for AD. I'm now going to find the slope of BC. And for B, my point is A0. And for C, my point is B plus A, comma C. So again, I'm going to go x1, y1, x2, y2. And my slope is going to be y2, which is C, minus y1, which is 0, divided by x2, which is B plus A, minus x1, which is A. And C minus 0 is C, and B plus A minus A, the A's are going to cancel, you're going to get B. And again, I get C over B for the slope of BC. And since they both have the same slope, and since we already had demonstrated that this was the same distance, then we have one pair of sides that is both parallel and congruent, and therefore this is a parallelogram. And that's pretty much all you have to do as far as a coordinate proof for this statement. So now we're going to ask you to do this little guy, to write a coordinate proof that if a quadrilateral is a parallelogram, then opposite sides are congruent. And so once you have completed this do-it-yourself question, then you will have completed your notes for this lesson. And I will see you in class, and thank you for watching.